So hello everyone, welcome you all to this video. So as I've told you in my previous session that I have already completed module 1. So according to your syllabus, now the module 2 is about vector space and linear transformations, right? So when in our time it was module 3. So this is module 2 for you guys, okay? Vector space and linear transformations, okay? So again, the whole of the module 1 is been covered in my previous videos, okay, of vector calculus, okay. They are both the chapters, vector differentiation as well as integration. Detailed videos are available in this playlist only, okay. Around 15 videos are there. So those who have not watched it and those who are new to this video, please go and watch it, and please like this video, subscribe to our channel for the latest notifications and latest updates, okay. Please do that. So yeah. Let us start with this module now. In this, let us discuss first with the vector space. In that we are having first this subspace. Okay, what is this subspace basically? Let us discuss. Subspace is a non-empty subset of W. Okay, W is of any vector space or a whole any number. Okay, of a vector space V of F. Okay, this V of F is a vector space. Is said to form a subspace of V if W is also a vector space over the F, okay, with the same addition or scalar multiplication for V, okay. So what it means to say that is said to form a subspace of V, that is this W should be subspace of V only if and only if the vector space over F follows some arithmetic calculation such as scalar addition, scalar multiplication, etc. in this V, okay. Yeah. So this is an example given here, that is, let W1 be a set of A, 0, where A belongs to R, okay, where A belongs to set of R. A set of R is a set of real number. So the W2 is equal to A, B, 0 for values of A and B belongs to R, okay. Then we can say that W1 is a subspace of W2. Also W1 and W2 are the subspace of R cube, that is the third order real number set, okay. Yeah. So this is the basic definition of a subspace. So now we have some conditions for subspace. Under conditions we have first theorem 1. W is a subspace of V of F, that is a vector space. If W is a subspace of vector space, only if W is a non-empty set, okay, it should be a non-empty set. W is closed under vector addition, that is, if for all the values of W1 and W2, if it belongs to W, then W1 plus W2 also would be belonging to W, okay. It is closed under vector addition. The next condition is it is closed under scalar multiplication, that is, if for all the values of A, if it belongs to F, then for all the values of W it belongs to W, that is A dot W, that is under scalar multiplication A multiplied by W we would be getting under the set of W itself, okay. So this is the first condition, theorem 1. So similarly theorem 2, that is, if W is a subspace of V of F, if W is a non-empty set and for all the values of A, B belonging to F and V, W belongs to the set of W, okay. So then we could be saying the condition that A dot V, that is A multiplied by V plus B multiplied by W also would be belonging to W, okay. So this is the theorem 2 condition, this formula, okay. So you should be keeping this in mind. Related to this, in order to prove that subspace conditions and all, we have two important problems. So let us see that and let us try to understand, okay. Yeah. Phi is a null set, then we can say that L of S is equal to 0, okay. So this is about linear span. Next, basis or base of vector space V, okay. Let V be a vector space over the field F. The set of vectors V1, V2 up to Vn is called as the basis of V if, how it is called as the basis of V, let us see. If the values of V1, V2 up to Vn are linearly independent and as well as V1, V2 up to Vn are the linear span of V, i.e. each vector can be uniquely expressed as the linear combination of V1 up to Vn, okay. So in this way the basis or base of vector space V is satisfied. Firstly, the values of V1 up to Vn should be linearly independent and it should be under the span of V, okay. Then only we can say that it is called as the basis vector, okay. So this is the next problem. determine whether or not each of the following form a basis, that is basis in R cube. Okay, so here they have given three vectors here, x1 2 2 1, x2 is 1 3 7, and x3 is 1 2 2. Okay, so if they give, sometimes they would be giving you directly to check whether linearly dependent or independent, or sometimes they would be giving you whether or not the vectors are form a basis in R cube or not. Okay, so here basis means in order to form a basis in R cube, the vectors should be linearly independent. Okay, when the vectors are linearly independent, then only it can form a basis in R cube. Okay, so that's one condition. If they ask the question that whether they would be asking question if they form a basis or not. So if the basis word is mentioned, you should be remembering that basis corresponds to linearly independent. Okay, if the problem is in the linearly independent, then it forms the basis in whatever the order mentioned here. Okay, yeah, so we should be checking whether these three vectors are linearly independent or not. If they are not linearly independent, then it does not form a basis in R cube. Okay, so yeah, let's solve the same thing. X into, or they have given x1 x2 x3. Okay, so let's take a, no, let's take x only, plus y into x2 plus z into x3 equal to 0, right? So x into x1 they have given it as 2 comma 2 comma 1, x2 is 1 3 7, and x3 is 1 2 2 equal to 0. Okay, so 2x comma x plus y comma 3y comma 7y plus z comma 2z equal to 0. So we would be getting the equations as 2x plus y plus z equal to 0, 2x plus 3y plus 2z equal to 0, x plus 7y plus 2z equal to 0. Okay, so these are the three set of equations. Again, let ax is equal to 0. Okay, so A matrix would be equal to the coefficients 2 1 1, 2 3 2, 1 7 2. Okay, so what I'm doing here, I've told you, right, whenever in the first row the first element should be equal to 1, then only the problems would be becoming easier. So what I'm doing is I'm interchanging third row and first row, that is R3 R1. So rewrite the matrix after interchanging the rows. So 1 7 2 would be coming here, 2 3 2, 2 1 1. Okay, now these two elements you should be making equal to 0 with respect to R1. So R2 first would be R2 minus 2R1, R3 also would be R3 minus 2R1 because both the terms are 2 itself. So after making that, write it again, 1 7 2 as it is. These two elements are 0. So R2 minus 2R1, 3 minus 2 into 7. So 2 7s are 14. So 3 minus 14 is minus 11. And here 2 minus 4 into 2, 2 minus 2 into 2, that is 4. 2 minus 4 is minus 2. And here R3 minus 2R1, that is 1 minus 2 into 7, that is 14. 1 minus 14 is minus 13. And 1 minus 2 into 2 is 4. So 1 minus 4 is minus 3. Okay, now this term we should be making equal to 0. So R3 with respect to R2, so again complex conjugate multiplication. First 11 minus 11 R3 plus 13 R2, or we can write it as 11 R3 minus 13 R2. Okay, so do that and write the final matrix. 1 7 2 0 minus 11 2 0 0, and here minus 3 into 11 minus 13 into minus 2. So 11 threes are 33, 26, right? So minus 33 plus 26, that is minus 7. Okay, so this is the required A matrix. So here rank of A is equal to number of non-zero rows, that is 3, and also number of unknowns equal to 3 itself. So rank of A is equal to number of unknowns. So it consists of a unique solution. So it possesses a unique solution, and I've told you, right, for unique solution all the values of x, y, z are equal to 0 because of number of unknowns. All of them are equal to 0. So we can directly conclude that they are linearly independent. Okay. Since they are linearly independent, therefore it forms a basis in the given order R cube. Okay. Yeah. So this is the answer. Like this you should be solving this problem. Please note it down. Okay. For this you should be knowing very well the rank to find the rank of a matrix, and you should be knowing the conditions for ranks and number of unknowns. If you know that, only you would be solving these problems very carefully. Okay. Yeah. So that's all for this video. These are the some set of problems you should be knowing. Yeah. Let us see you in the next video with some other concepts. Okay. Like this video, share this channel. Thank you. So this is the next question, 3C. They have given, prove that the transformation from R cube to R cube, that is the third order to third order, should be defined by T of ABC. They have given the T of ABC as 3A comma A minus B comma 2A plus B plus C is a linear transformation or not. You should be proving with respect to the conditions given whether this satisfies the condition of linear transformation or not. So this problem is very easy. Linear transformation condition you already know. I already discussed in my videos. That is, there are two conditions under linear transformation. That is, first condition is T of U plus V is equal to T of U plus T of V. So in case of the third order, it would be T of U plus V plus W would be equal to T of U plus T of V plus T of W. That you should be proving first. The second condition is T of AU should be equal to A times T of U. If these two conditions are satisfied properly, then only you could be calling it as a linear transformation. So let us see now whether this is a linear transformation or not. So in this case, you should be considering the U vector as U is equal to A1, B1, C1, where A1, B1, C1 are the vector coefficients. V is equal to A2, B2, C2, and W is equal to A3, B3, C3. Because it is from R3 to R3, so that's why you should be taking 3 vectors along with the 3 vector coefficients, okay, belonging to R cube. So now, since we have 3 vectors, so we should be proving for T of U plus V plus W, okay. So how it is given by T of U plus V plus W is equal to T of U is A1, B1, C1, right? So U, that is A1 plus A2 plus A3, all the components, okay, comma B1 plus B2 plus B3, all the B components, comma C1 plus C2 plus C3, all the C components. Now with respect to this condition, now you write they have given first 3A, so 3 times of A1 plus A2 plus A3, that is 3A1 plus 3A2 plus 3A3, comma next is A minus B, right? So A minus B, A would be replaced by A1 plus A2 plus A3, and B would be replaced by B1 plus B2 plus B3. Why this is minus? Because they are getting subtracted, so all these terms would be getting minus, okay. So minus B1, minus B2, minus B3, comma 2A plus B plus 3. See, again A would be replaced by A1 plus A2 plus A3, so 2A1 plus 2A2 plus 2A3 plus B, that is B1 plus B2 plus B3, plus C, that is C1 plus C2 plus C3, okay. Now here group the terms in such a way that you should be satisfying the condition of transformation. That is, first as it is 3A1 plus 3A2 plus 3A3, now A1 minus B1, group it in one side, plus A2 minus B2 plus A3 minus B3, comma here also for all the first terms, that is different components of all the different orders, you should be writing it together, that is 2A1 plus B1 plus C1 plus 2A2 plus B2 plus C2 plus 2A3 plus B3 plus C3, okay. Now the final thing is, with respect to the question provided, you should be substituting. That is, first is 3a1 comma all the first components, that is a1 b1 c1, you should be writing with respect to the equation provided here. That is, first is a would be replaced by a1, that is 3a1 comma a1 minus b1 comma 2a1 plus b1 plus c1, write it in one bracket, plus for a2 now the second component 3a2 comma a2 minus b2 comma 2a2 plus b2 plus c2 plus 3a3 comma a3 minus b3 comma 2a3 plus b3 plus c3. Okay, so here this is simply t of u, this is simply t of v, and this is the t of w. Okay, so you see here t of u plus v plus w would be equal to t of u plus t of v plus t of w. So this is one condition which is satisfied in the linear transformation. So note it down. So this is the second condition, that is also for a belonging to r and u belonging to r square. In this case it is r cube. So t of a into u, that is one a term will be getting multiplied, that would be equal to t of aa1 comma ab1 comma ac1. So here in this case, again with respect to the question 3aa1 comma aa1 comma ab1, in all the terms the a term would be getting multiplied in every term. So that's why we have written it as aa1 comma ab1 comma 2aa1 plus ab1 plus ac1. So here a is common, take it outside and write the other terms left out, that is 3a1 comma a1 minus b1 comma 2a1 plus b1 plus c1. So this is nothing but t of u. Okay, since this is 1, so the first components represent the t of u, so that's why a into t of u. So t of au is equal to a into t of u, that also is satisfied. So these two things are satisfied, so directly write the final answer as, therefore t is a linear transformation. Okay, so hope it is clear, very easy, try to understand it and solve it. So that's all guys, note it down.